Hello, and welcome to this review of factoring. So this is just part one, so we're going to talk about the GCF and basic trinomials, which I like to call the more memorable kinds of factoring. If you totally forgot though, don't worry about it. So I just want to give you a quick overview of this series. So in this part one, I just kind of want to like dip our toe back into factoring. I'm assuming that maybe it's been a minute since you've seen it. So I'm going to talk about the types that people are more likely to remember, and even if you forgot, no big deal. And then I have parts 2 and 3 of these videos, and we'll get progressively harder with the different types of factoring plus tips and tricks. Okay, so let's just jump right into it. We're going to talk about the greatest common factor, or the GCF. And if you're saying, what? I don't remember that. No problem. We're going to go through everything. So I like the GCF because I think it's just like one of those ones where if I didn't give you any instructions, you'd probably actually know what to do. So if I asked you to factor 3x plus 3y, what is like the clear thing that these have in common? It's a 3. And that 3 is the GCF. So what I would do is I would take out what they have in common. So I'm going to take out the 3. And I effectively really divide both of these terms by 3. So if I divide the 3 out of this, then I'm just left with x. And if I divide the 3 out of the second term, I'm just left with y. So there you go. That's using the GCF. So you look for what's the largest thing that divides into both terms, write that in front, and then divide it out and write out what is the result. Okay, so this is an example of factoring by the GCF, or greatest common factor. And so what if I wanted to check this? So the nice thing about this is that there's a really quick check if you aren't sure if you got it right. So all you have to do is multiply back in. So you're going to distribute the 3 to the x and to the y so that you get 3x plus 3y. And so then, okay, we've got it. We're good to go. Hunky-dory. All right. So why don't we try another example now? Let's factor 4x plus 12x squared minus 8x cubed. Okay, now you might want to pause here just to give yourself a second to think about this. And like, what do you think the GCF is here? I want you to actually pause and try it on your own. Worst that happens is you get it wrong, right? Okay, so what I notice is that all of the terms have an x in common. So they all at least have one x, right? So x versus x to the third, not all terms have an x to the third, right? So they all have an x in common. So this is a little different from where we started. And then all of the numbers are divisible by 4. So the GCF in this case is 4x. Okay, so if I factor out the 4x, so here's where this could get a little bit tricky. I did throw in a little bit of a curveball for the next one. So 4x divided by itself is not 0, right? Anything divided by itself is equal to 1. Sometimes it throws people off. Okay, so then the next one, so then I take 12x divided by 4x. So I'm effectively taking out one of the x's, and so I'll be left with one more x. And then 12 divided by 4 is 3, so this becomes 3x. And then finally, this will be 2x squared. Okay, so here you go. This is going to be the GCF for x, and then here I am factoring it out. The one thing I would like to point out here, I started with 1, 2, 3 terms. Notice that when I factor out, I still have 1, 2, 3 terms. So sometimes, the thing with like math is that everybody's brains, we have a tendency to kind of like skirt around the rules of math. Everybody's brain does this. One of the things that I notice is that sometimes when people try to factor out 4x, they want to put a 0 here. So just notice if you are prone to that particular error. And again, the quick check is just, I started with 3 terms, I should end with 3 terms. So that's like the quick gut check if you find that you are prone to that. Now, before we get to the next example, I do want to just take a moment to remind you, how do you get the most out of this video or any of my videos? Well, you need to pause when you need to, write things down, and try things yourself. I always say that math is not a spectator sport. And so if you are just sitting here watching the video and you never pause, it's going to go too fast. To make this your own pace, you really are kind of expected to pause from time to time and take as much time as you need to. I can't build that into the video because everyone's going to be different as to how much time they need. So please just remember to pause, write things down, and try things yourself. Okay, so here's this next one. looks a little bit more intimidating. I want you to give it a try. And the worst that happens is that you get it wrong. But if you try this and you don't get it right, what's the worst that happens? Nothing. I mean, like, you just got it wrong and then you write something else down. So make your best guess. Hit play when you're ready. Okay. So in this case, everything is divisible by 5. So that's going to be the number part of the GCF. And then I notice here, so I've got x squared, x to the 7th, and x to the 5th. So at a minimum, all of these have a factor of x squared in them. And then I've got y cubed, and y squared. So at a minimum, all of these have a y in them. So we've got really the first term again is the GCF. Okay, so let's go through how do we actually factor this out. Well, this divided by itself is just 1. For the next one, this will be 2x to the 5th y squared. Okay, so I want you to notice what I really did with the exponents. So when I divided this term by 5x squared y, I reduced this exponent by a factor of 2, right? So I really just took 7 minus 2. And then same thing with the y's, right? So I've got y cubed, and I'm taking away 1y, so I'm left with y squared. So you're literally just subtracting out whatever these variables exponents are here, which makes the last term minus 3x cubed y. Okay, so here is my answer. And sorry if you can hear my dog barking, by the way. Okay, so the other thing I want to point out with this is a shortcut for the GCF. So one thing that I use from time to time is, so if I notice, okay, I've got an x here, x here, x here. The GCF is always going to be whatever the lowest of the exponents is. So in this case, this was the lowest exponent, so there's my GCF. And notice if I repeat that with the y's, so I've got y cubed, y squared, so I look for what's the lowest exponent. This is an invisible 1, so that's going to be my GCF. So that's another shortcut if you were like, oh, I don't know how I would pick that out. That's the shortcut that we're using. Okay, so now I have 2 here for you to try. So I want you to try these totally on your own and hit play when you're ready. Really pause, think, take as much time as you need. Hit play when you're ready. Okay, so for this first one, so all right, let's see. 4x squared, 12xy, and 3y squared. Well, okay, first of all, as far as numbers go, I've got 4, 12, like nothing divides all 3 of these, right? So yeah, sure, 4 might divide these 2, but it won't divide this one. And 3 will divide these 2, but it won't divide this one. So, okay, there's no number part of the GCF. And then let's see, I've got x squared, xy, and y squared. Okay, so same problem here, actually, right? Not all 3 terms have an x, not all 3 terms have a y. So this one is what we call prime. You know, I got to keep it interesting, right? So this one cannot be factored, and that's totally a thing. So not everything has to be factored, so that's just kind of there to keep you on your toes. Okay, so what about the other one? So let's see. Everything in this case is definitely divisible by 5. And then let's see. I've got an x in each term. The smallest exponent is the 3, so this will be 5x cubed. And then I've got y to the 4th, y squared, and y to the 8th. So this will be the other part of the GCF. Okay, so now let's divide it out. This becomes 3y squared, right? Because I've got x cubed, so the x's just fall out. Then I've got minus 5x cubed, and now the y's fall out. And then plus 4x to the 4th, y to the 6th. Okay, and so that is all we can do for that one. Okay, so that is the idea of the GCF. So now let's just talk about what is a trinomial. So a trinomial, this is a polynomial of the form ax squared plus bx plus c. If you forgot what a polynomial is, don't worry too much about it. This is an example of a polynomial. Lots of things, everything that we've looked at so far is a polynomial, but a trinomial is a 3-termed polynomial, and the a, the b, and the c all stand for different numbers. And maybe the one other thing that I want to add on to this is that a cannot equal 0, but b or c could equal 0. Okay, so the other thing I want to mention here is, so what would a trinomial actually look like? Because I've got ax squared plus b plus c. Okay, not the most helpful. Here's some examples just of what it looks like. So I've got like 3x squared plus 5x minus 2, or x squared plus 3x plus 2. So what would the a be in this case? The a would just be an invisible 1. Okay, check out this one. X squared minus 4. So this technically falls into this format. So in the back of our minds, the b would just be equal to 0. So x squared minus 4 is the same as x squared plus 0x minus 4, so we just write x squared minus 4. So the next thing that we're going to talk about is factoring things that look like this. Now, before I talk about that, what I want to do is I actually want to remind you of how do you even multiply things that look like this. And so if you are maybe a little rusty, I think this would be a great time for you to pause the video and just see if you can remember, like, how do you multiply this together. Try it on your own before I tell you, and then hit play when you're ready. And remember, math is not a spectator sport, so give it a try. Okay, so let's do this. So to multiply, so if you forgot, no big deal. We're going to review it. It's just, explanations are more meaningful if you try it on your own. If you just always see how things are done right, you're less likely to remember them than if you tried, got it wrong, and then saw how to do it. Okay, so I've got x times x. So x times x is going to make x squared. I'm going to have x times 7, so that's going to be 7x. I'm going to have 2 times x, so that's going to be 2x. And then I will have 2 times 7, so that's 2 times 7 is 14. Okay, so I want you just to appreciate like what I did. So a lot of times people bring up the word FOIL. I want to point out FOIL is a 4-letter word, starts with F. I don't like the word FOIL actually, because I feel like it makes people forget how to multiply more complicated things. So at the end of the day, and if you use FOIL, it's not a big deal. I'm just making a joke here. But okay, so if you are multiplying these things together, it's really everything in here needs to get multiplied by everything in here. And so appreciate how I did that. I took the first term, right? And then I multiplied it by both things in here. Now I've exhausted everything multiplied against the first term. Then I pivot to the next term. I take this term and I multiply it by all things in here. Same thing as FOIL. It's just the true process of kind of multiplying everything together. So then after I multiply all that stuff, I'm left with x squared plus 9x plus 14. And so there you go. So this is a really essential skill when we are factoring trinomials, because this is how we check factoring trinomials. And I just want to kind of plant this seed in your head. If you're rusty at this right now and you have to multiply this all together, that is totally fine. But I want to point out like what my goal is for you. So let me just rewrite this one more time. And you don't have to like write this down or anything. I'm just trying to get you to see the long-term project here, or where we're going. So ideally, I would want you to be able to kind of check this in your head. And I'll bring this up a few times, but I just want to present this now. So I have x times x is my x squared. Now, I know the nature of how this is going to work. I know when I multiply things together that look like this. Notice that this came out to 1, 2, 3 terms. I know that these types of things become trinomials. So what I really want to do is I want to prevent this work of having to multiply out the middle term. Now, it might take you a little bit of practice to get comfortable with doing this, totally fine. But watch how I do this, okay? So I'm going to have x times 7, so that's 7x, and then 2 times x is 2x. So I've effectively got 2x times 7x. That's going to give me that 9x. So see how I can kind of do that middle part in my head? That will be your eventual goal. And I'll bring that up a few times. And then I finally have the last 2 terms, so 2 times 7 is 14. So just appreciate kind of how that works, because that's going to help you with checking things. Sorry about that. Okay, so let's keep going. All right, so now let's actually talk about factoring. So I've got x squared plus 3x plus 2. So in this video, I want to talk about using trial and error. And so before we get into that, I want to throw out, I'm using trial and error. And you might be saying, but wait, I learned a factor doing these other ways. So there are several methods for factoring. And what I want to mention here is that the trial and error method is going to be the fastest method. So it's important for you to feel comfortable with this. So let's talk about how to just use this method. So I've got x squared plus 3x plus 2. So the trial and error method is basically, I know how trinomials work. So I know I'm going to have one thing times another thing. And the only things that I focus on with this are, what do I multiply to get this term? So what times what will make x squared? So that's going to be x and x. And then what do I multiply together to get this term? And in this case, there's only one way to get 2, right? That would be 2 and 1. Now, sometimes when you have just x squared like we do here, you can also take this a step farther and say what two things multiply to 2 but add to 3. So 2 plus 1 is 3, and 2 times 1 is 2. So that's like the really quick way to use trial and error. And then look at how I can check this. I have x times x is x squared, and then the middle term, 2x plus 1x. So that's 2x plus 1x is 3x. There's my middle term, and then 2 times 1 is the last term. Now, if you're not sure about this, if you can't do this in your head, no problem. Then you just write it out, right? And you just double check. And so then I see, yep, this gives me x squared plus 3x plus 2. So I can see that this definitely worked. So this is the idea of trial and error. And like I said, it's often the fastest method. So even if you learn something different in another class, you really need to know this method, because in a class like this where you use a lot of factoring, you are not going to want to have to sit there like doing an algorithm every single time. You're going to want to try to use the things that are fastest. In other videos, I will review some other methods. So just hold tight if you're like, oh, but I remember these things. I don't remember quite how it works. No problem. We'll talk about them in other videos. Okay, so let's factor just a couple of these things together. So I've got x squared plus 5x plus 6. So, okay, same idea, right? So I'm going to set up my two brackets. And how do I get x squared? That's going to be x times x. Okay, so then I can say, what two things multiply to 6 but add to 5? Well, 2 times 3, right? So 2 and 3, that will get me the 5x in between. So this is how this is going to factor. And then again, I can kind of check x times x is x squared. And then I've got this 2x plus 3x. So that gives me the 5x. 2 times 3 is 6. So we're all good here. Okay, so what I want you to do is I want you to pause the video, try this one, and hit play when you're ready. Okay, so for this one, now you've got to think a little bit more because you've got a minus 7x in the middle. So you've got x and x to start for sure. But now it's what two things would multiply to 12 and add to negative 7. Okay, so the only way that these are going to add to negative 7 but become something positive when you multiply them together means that the two things that we're multiplying, both of them have to be negative, right? If two things are negative, then that will make a positive when you multiply them together. So two things that are negative that add to negative 7 would be negative 4 and negative 3. So I have x minus 4, x minus 3. Okay, so there we go. And I've got minus 4x, minus 3x, that gives me the minus 7x, and then negative 4 times negative 3 will make positive 12. So we're all good to go here. And here's one more for you that I want you to try, x squared minus 25. So again, this is that idea then of that middle term is technically a 0. So why don't you pause for a second, give it a try, hit play when you're ready. Okay, so this is actually a pretty well-known type of like trinomial, and the way that it factors is known as the difference of squares. So this is a square and this is a square. So why is 25 a square? Well, 5 times 5, that's what's known as a perfect square. 5 times 5 will make 25. So this actually has a really standard set of like how something of this form factors. So I have x and x, and then so I need to get negative 25. So this will be plus 5 minus 5. Okay, so notice what happens. 5 times negative 5 gives me negative 25, and then 5x and negative 5x will make the middle term drop out, right? So you can prove this to yourself, you know, pretty quickly if you are kind of questioning it. So now I can see that the 5x drops out, so I'm left with x squared minus 25. Okay, so just remember the form of this. I'm not a huge fan of like remembering formulas necessarily. I like to just know why things work. A lot of books will talk about, oh, this is like a standard formula. But like this makes sense, right? Like forget about having a formula. Yes, there is a formula, but why make you memorize a formula when the reason why this works makes sense, right? The middle term drops out when we multiply it all together. And so the idea here is if this is a perfect square, then you have the plus and the minus version of the thing that makes that a perfect square. Okay, so let's keep going. I have just a couple more that I want to talk about now. So let's talk about something a little harder. So when I have just x squared, that's a much easier case than if I have 2x squared plus 5x plus 3. So now that I have a 2x here, this actually makes things a little bit more difficult. And this is where people can get a little frustrated with trial and error. And so I want to talk about, like, what do we do when this happens? Okay, so at the end of the day, the whole thing with trial and error is, first I just think, what two things multiply to the first term? And I try not to give myself too much mental drama on how to do that. So in this case, I need to have 2x squared. The only way I'm going to get a 2 is if one of these has a 2 in front of them. So I'm going to have 2x and x, and I'm not going to worry too much about, like, you know, where to put them. I'm just going to write something down, and this gets me the first term for sure. And then again, so trial and error. I'm really just worried about the first and the last term. So I multiply these things together. So what makes 3? Well, 1 and 3 will make 3. Okay, so now this is my trial. Let's see if I made an error. So I multiply these things together. I get 2x squared, x, 6x, and 3. And so notice this is going to give me 2x squared plus 7x plus 3. So no dice. That's not what we needed, right? So when I put a number in front here, this kind of changes the nature of things. And we can't quite so easily just be like, oh, what two things multiply to 3 to add to 5? It doesn't work like that now. I'll show you in some other videos some other tricks for this, but the trial and error is still the easiest one to remember. So I want to just talk about, how do I troubleshoot this? Okay, so I think one of the things that's very important is to then ask yourself, why is this wrong? This is wrong because the middle term is too high. And why is the middle term too high? What made that happen? Well, what made that happen was that I took the 2x and I multiplied it against the 3 to get the 6x, right? The second these two things bounced off one another, I had a term that was too high. So the thing with trial and error is that you want to make smart guesses. So you make a guess and then you troubleshoot it. So I don't want a bigger number bouncing off of the 2. So what's the solution for that then? How do I deal with that? Well, all I have to do is flip-flop the 1 and the 3. So let me clear this some space and try it again. Okay, so now I'm going to do 2x and x, and I don't want the 2 bouncing off of the 3. So I'm going to flip the 3 and the 1. So now let's check. So I've got 2x squared, 3x, 2x, and 3, and that gives me 2x squared, 5x, and 3. So bada bing, bada boom, we're good to go. Okay, so this is usually the type that gets a little bit more frustrating for people. But the key is that when you make a guess is to then evaluate what you did and try to make a better guess the next time. So this will also really get you a lot more comfortable in multiplying things together. And look, I could still do the middle term in my head. 3x plus 1 times 2x is 2x. So I can see I've got 3x plus 2x. That would have given me 5x. So you can still check this in your head too. Okay, so what I want you to do now is I want you to try factoring this totally on your own using trial and error. Hit play when you're ready. Okay, so this one is going to factor, let's see, 5x and x. And I'm just going to tell you the right answer because we're getting a little long in the video here. So this will be plus 2 and plus 1. That's the best way to factor this, because then this becomes 5x squared, 2x, 5x, and 2. And so that'll give me the 7x that I need in the middle. So that's ultimately how you would factor that. And I've got one more here. So again, math is not a spectator sport. I know, we're at the end of the video. Maybe you're a little tired, but I want you to try it anyways. Hit play when you're ready. Okay, so now what makes this one kind of hard is that this is negative, right? So this is negative, so that means one thing's got to be positive and one thing's got to be negative. Now, I am not going to let myself have too much mental drama as to where I put things. At the end of the day, trial and error is first, just make a guess, and then we'll go from there, right? So what I'm going to do is I am going to put a plus, let's see, what things make 10? 2 and 5, right? and one has to be positive, one has to be negative, so I'll make this one plus 5, I'll make this one minus 2. So let's see what I get. I get 3x squared 15x minus 2x minus 10. And so that gets me indeed what I need. So this one, oops, plus 13x minus 10. So this worked out. So if you did any other combination, so like if I made the 5 negative and the 2 positive, I would have gotten the wrong middle term, but that's like an easy fix, right? So these are the things that you kind of want to think through when you're doing this. Okay, so that is just a quick review of the kind of more memorable types of factoring. I do have some other videos of just more examples. If you're like, I need more, no problem. I've got more examples to check those out. If you found this helpful, please consider hitting the like button or sharing or commenting on it. And otherwise, I am going to leave it at that, and I will catch you guys in the next video. Thanks for watching.